beginning on page 168, number 1. There's a little pretty picture of a mouse. It's a white mouse. Hey, they collected data on the weight of a male rat. Oh, not cool anymore. Thought it was a mouse. For the first 25 weeks after its birth. So we're looking at the weight. They've made a scatter plot for the weight in grams and time since birth in weeks. And they show a fairly strong positive linear relationship. The linear regression equation is weight hat equals 100 plus 40 times time. And they say it models the data fairly well. I'm going to go ahead and write this like this. Alright, and hey, just because I have my y-intercept first, it doesn't all of a sudden make it the slope, right? So just be careful with that. People do it all the time. Okay? Just remember back to your algebra now, when you had your y equals mx plus b. I could also call that b plus mx, couldn't I? So it doesn't seem like something I need to say, but it is. It's something that needs to be said. Just remember, your variable quantity there is going to be, sorry, the coefficient of your variable property is going to be your slope. Okay, well, you're being asked a question. What is the slope of the regression line? Explain what it means in context. So what? The slope is 40. Okay. What does this mean? This means that we expect, and let me actually formulate my sentence before I write it down. And our time is in weeks. So we need to actually express this in terms of units, right? This means that we expect that for every one week increase in time alive, I guess. There's a word for that, it's called age. In age. The weight should increase by 40 grams. Boom. Again, remember, we want to say we expect, right? We don't want to make any definite statements about this because we're making predictions, okay? These are predictions. Okay, 2. What's the y-intercept? What does it mean in context? The y-intercept is 100. So, y-intercept equals to 100, but is in grams. Is grams, and so we'll have to say that we expect that the baby white rat is 100 grams. Yeah? Sure. Means baby white rat. Okay, so because that's at week 0, right? So this means that we expect a baby rat to weigh 100 grams. Okay. Hey, let's predict this rat's weight after 16 weeks. So, if we're going to make a prediction, we're going to use our regression equation, and then we're going to input, how many weeks again? It was 16 weeks. There it is. So our expected weight after 16 weeks should be 400 plus 240, 640, 740? Yeah. Mental math. All right. Not sufficient, as long as I included my units, right? Yeah, that's good. If I don't put grams, it's wrong. So you have to put units, because that's the contextual part, right? You have to make sure that you're expressing your answer in context. So you're not just giving a number that you're talking about in the problem. You can even be super precise and write the sentence. The expected weight is, whoa, the expected weight, 740 grams. That's even better. All right. Number 4. I have fancy headphones for this, but then I can't hear you, so it's fine. Okay, so should you use this line to predict the rat's weight at age 2 years?
No, don't be silly. That's extraneous data.
Yeah, we would be extrapolating at that point. We would really like to interpolate.
Yeah.
Right, because our range, the range used to compute the least squares regression equation is from 0 to 25, right?
Yeah.
And let's assume that I'm talking about an interval. The value at 2 years, the value x equals 104 is far outside this range. Outside of this range, we'll use proper English today. I didn't even mean to do that. Hold on a second. I almost started writing this range. And thus, we would be extrapolating. Extrapolating? Wow. Okay. So they would like to know why this is going to be unreasonable. Because it's going to be a huge rat, right? It's going to be just stupid. Stupid big rat, yo. Because if we were to do it, we would have y hat equals 100 plus 40 times 104. Did anyone calculate that using their calculating computer handheld machine device? What? I mean, we could calculate, yeah. Why? Hey, well, there are, okay. By 454, because that's how many grams are in a pound. So, that is approximately 9.383 pounds. It's the size of a small dog. It's not a big dog. My dog weighs like. Yeah, no, it's big dog. I think a 9-pound dog is pretty small. I had a metric person who uses pounds in America. All right, on page 172. It's time to practice your calculator regression skills. Using the familiar SEC football data in the table below, let's repeat the steps in the previous technology corner. And you should get y equals negative 3.7506 plus 0.4372x as the equation of the regression line. And what I'm going to do is just go ahead and write down the steps for you. So, and these are the steps for a TI in SPIA. Okay? So the first thing you're going to do is make a new document. You want that first page on that document to be a list and spreadsheet page. You're going to name the first column right? And that's going to be in that very, very top box. And we're going to name it, it does not say which should be our explanatory and which should be our response variable. So let's go ahead and name this one first column points per game. And then we're going to name our second column. Well, let's put that, and then we'll enter points per game. Data in this column. We'll do the same thing with the second column, but we're going to name it wins. Yes. And it makes sense then that our explanatory variable would be points per game and our response variable would be wins. We want to see if there's a correlation between points per game and number of wins. And we'd like to know a lot about that correlation, right? Is it positive? What direction does this data flow in? Right? All right, we're going to I'm going to write it so it's specific instructions. Name the second column wins and enter wins data. Next thing. Now that we have our data, we're going to insert. So we're going to go doc. Insert. And we want a data and statistics page. We're going to have to name or assign the variable, assign the variable that we gave the column, right? That's why we need to name the column so that we can assign a variable to the x-axis, assign the variable points per game, I'm going to just write PPG, to the x-axis, right? Because we have decided that that is our explanatory variable. Then we're going to assign the variable. Are you guys seeing this in your head right now? It's pretty awesome if you are. No? Wins to the y-axis. When you do that, all your data is going to form a nice little scatter plot. Then you are going to go to, so now at this point you have options, right? You could just use your calculator, right? So you could open a calculator page and go to the statistics, and you could do static calculations, and I think there's a regression linear mx plus b or b plus mx. Or right there on your screen, you could hit menu and go to regression or analyze. So we'll just do this so we don't have to make a new page. We're going to hit menu. Analyze. and then it was regression, right? And we'll choose whichever one, y equals x plus b. And let's actually choose linear, and let's do b plus mx. Guys, you're probably on the exam going to see it in that form, b plus mx. I mean, you might as well just get familiar with that. I introduce it as mx plus b because that's what you're more familiar with seeing. But now we're going to switch. We're going to go over to b plus mx. It's not a big jump. Yeah.
We're about to take the transplant on the test, right?
Oh yeah. You just can't have inspired casts on that test. So the CX is great. The cast will get rejected because it falls. Which I don't know why that's a big deal for AP statistics, but it is a huge deal for calculus because that's the only actually do integral scoring and stuff like that. The cast, well, the cast is super. All right. Wow. Okay, that's done. We did that. Check your understanding. Let's do another one. On 174. Here's 174 page. Hey, and you guys should find that these check your understandings are real similar to the questions being asked of you on your take-home quiz. They're real close. Real close. And then the take-home quiz is real close to the free response questions on your test. You see where I'm going with this? All right. Okay. Hey, Ford F-150 miles driven and price data. Good grief, where is that data?
Previous.
How much is that truck worth? Okay, so they gave us our equation. Y hat is equal to 38,257 minus 0.1629. And it says miles driven there, so it must be the case that our explanatory variable is miles driven, and our response variable is price. Boom, boom, shakalaka. All right. I wanted to find the residual for the truck that had 8,359 miles driven. Okay, so we're looking at, we have an x value. We actually have a value on this that actually has the coordinates. 8,359 8,259. This actual data is somewhere else. Here we go. The value was 31,891. Cool. So we're going to find the residual for this particular data point. Remember that our residual is our actual y value minus our y hat value, right? So our residual okay, our actual value minus our predicted value. There's another way to say that. All right? Yes. Okay. So that means that what I need to do let's figure out what y hat is. Okay? The way that I find out what y hat is?
Plug it in, plug it in.
That's right. That was laid fresh. Alright. So, that's going to be equal to 38,257 minus 0.1629 times 8,359. So that turns out to be $36,895. Okay, when you put that in your calculator, so then our residual would be our actual data point minus our predicted which is going to be equal to $5,004. Dollar bills, y'all. Oh. That is just not good. There you go. Sorry about the writing. It says 5,004. All right. Hey, let's interpret the value of this truck's residual in context. Okay. What does that mean? It means that the actual value, huh? Oh. All right, let's look at it. Okay, so our actual value for 8,359,000 miles was 31,891, and our residual and our predicted value was 36,895, right? Which turns out sorry, that should be negative. I ran out of room. I need to rewrite this real quick so I can actually have something. Here. Our residual is equal to, and I want to make sure that those things, two things are separate, but this is. Sorry, I got squunched and it made me feel uncomfortable. I don't like being squunched. Negative 5,004. Sorry about that. There we go. All right, so that means that our actual value was $5,004 less than our predicted value, right? So 2. Our actual value is $5,004 less than our predicted value. Or the predicted value. I don't know why I use possessive pronouns on these things. I'm not sure why I do that. Then our predicted value. Same. For which truck did the regression line overpredict the price by the most? Overpredict. Overpredict. So what we're looking for, if we're talking about overpredicting, so the regression line overpredicts. So a picture of overprediction in this case would look like this. We have our regression line. I don't know All right, as the miles increase, the price should decrease, right? So an over prediction of price should have a point that's very far away from our regression line. You know what I'm saying? We could look at a residual plot if you wanted to put that data in there. That would be great. You could actually look at your residual plot and find the point that's farthest away from 0. And that's really the way that I would do this. So if we're looking at the residual plot, and also, okay, so this is if we're looking at the regression line. But if we're looking at our residual plot, okay, with these residual plots, we have 0 here, right? So for instance, our residual for the point 8,359 would be negative 5,004 somewhere down here, right? It would be negative. Remember, this is miles driven. And this will be our residual. So if we're looking at it in terms of a residual plot, let's just assume that the data looks something like this. If we're looking to answer this question, this point right here, this point right here would give us the one that has the most over-predicted value for our least squares regression. Yeah? Simon. Okay. Moving right along. Okay, next and last one. There's a scatter plot for hiker data shown in the table below. This hiker data all right, for this hiker data, it turns out that they were measuring the expected pack weight for a given hiker weight. All right, so they're saying that people that weigh more also have heavier packs. I don't know if that's true, right? Because you can only bring so much stuff. So,
maybe it's like a logarithm.
it must.
If they have more data, that's like 2 points.
Yeah, I would suspect that if you looked at a lot of this data, it shouldn't be that linear. All right, anyhow. One of the hikers had a residual of nearly 4 pounds, right? What does that mean? Easy, it meant that the hiker's pack was 4 pounds heavier than the predicted value. That is usually because the hiker brought heavy. But steak is good to have when you're. I've eaten steak. It's the one heavy thing that I love. So we have a picture of a this residual plot you can see on the page, and it's asking is a linear model appropriate? And so this thing looks kind of like this. We've got some negative data here. We have some certain negative residuals, and then we have it goes positive, and then it heads negative again, which is kind of what we were talking about, right? It looks like this data is nonlinear, and we see this rough pattern like this. Yeah. If we see a pattern, we go from negative to positive, back to negative, something like that. It's not good. It means that we don't want to use least squares regression for this particular. Right? And there's a frowny face. I mean, why would you want to use it? All right. Later on in the class, we'll learn how to actually take data like that and transform it using logarithms or whatever we need to do in order to make it so that we can use least squares regression. All right. Well, thanks, guys. You're welcome. Yeah. That's your check your understanding. We will actually add to this. It probably won't be on the video, but we'll talk about how outliers affect data. And then there is a fantastic multiple choice question